Good evening, everybody. Welcome to the April Recreational Astronomy Night meeting of the Toronto Centre RASC. My name is Paul Markov. I will be your host this evening. Are we, in fact, broadcasting on YouTube right now? We are. Well, for those of you watching on YouTube, welcome. Hope you enjoy the presentations. We typically have 3 speakers, but regrettably, Dennis Gray, who was going to present the sky this month, had something come up at the last moment, so he's not here with us tonight. That will leave more time for Michael Watson to talk to us about the Great American Eclipse, what you need to be ready, followed by Ralph Chu. He'll talk to us about eye safety and selecting solar filters. So as you might have gathered, this meeting is focused on the upcoming solar eclipse of August 21st. And we have 2 experts here to tell us all about it, in order to be ready and how to observe it safely. I'd like to find out if we have any new members here or people here for the first time, even if you're not members. Show of hands. We have 1. Welcome. Hope you enjoy the presentation. You'll be back to see us. And I think that's all. We can probably get started. Michael and Ralph, we would like to wrap up at 9:30, so we have nearly 2 hours. Tonight. Okay. Yes. I know Michael would like more time, so you have more time. So we've got the 2 of you plus announcements, a little under 2 hours. Come on up, Michael.
There we go. Okay, have audio now? Yes, all right. Ralph, when did you join the society?
1971.
All right, so I've got 1 year on you because I joined the RASC in 1970. And in 1970, we were looking ahead to a decade of astronomy, my first decade in the RASC. During that decade, there were 3 total eclipses of the sun that were visible in North America. The first one had happened actually just 2 months before I joined the society in March of 1970 and went up right up the eastern seaboard of the US. The next one was the July 1972 solar eclipse that crossed Northwest Territories and then down through the Gaspé and across Atlantic Canada. That was the first one that I actually went to, and the only one that I've been totally clouded out of. And then the third one, of course, was in 1979. That was in February, and that came through the US on the ascending node and then curved up through into Canada and across Manitoba, Brandon, and Gimli, Manitoba, where we saw the eclipse, and that was the second one I'd seen. So there were 3. So there were 3 coming up in that decade, but already back in the 1970s, and I remember this, people already were talking about this coming summer's eclipse, and it was 47 years away for a bunch of reasons. This is indeed the Great American Eclipse, and it's not because it is the longest eclipse. It absolutely isn't. The length of totality at maximum is 2 minutes 40 seconds, which is respectable, but I well remember in June of 1983 being on the island of Java and seeing a 6-minute 30-second eclipse, which is one of the longest that you can see. Now, it's a great eclipse for a number of other reasons, partly to do with weather, but also I think partly to do, or probably mainly to do, with the path and the area within which this eclipse is going to be seen. For one thing, the entirety of North America sees a partial eclipse, the whole thing. I'm going to show a graphic to demonstrate the shadow crossing North America. The second thing, because of where the path runs, and I think that probably all of you are familiar with it by now, but you'll see some graphics of that. My prediction is that this will be the most widely observed eclipse in history, except of course for all the people who will be kept out of the US at the border. But that's a different issue. What I'm going to do is ask if I hope that we can kill these lights so we can see the graphics better. So tonight I'm going to be talking about a number of things. First of all, and I should ask, just for the people who are here, just put up your hands. How many people are planning to travel to the path of totality for this eclipse? Okay, maybe about 40%. Last Friday night, Randy Atwood and I did a presentation at the Mississauga Center. And now, assuming that they were telling the truth, it was about 80%, 85% of people who were planning to travel to see that eclipse. How many people here have seen a total eclipse of the sun before? All right, a few of you. How many people have seen a partial eclipse of the sun? All right. Well, of course, everyone who's seen a total eclipse has also seen a partial eclipse for an hour and 20 minutes before, and actually not an hour and 20 minutes afterwards, because no one watches the partial phase after totality. So let's get going and then talk about this one. Uh-oh. Yes, here we go. All right. So what you need to know, and I expect that most people, if not all of you, know most of this, but we're going to talk about just a little bit about eclipses, and this is maybe for some people who skipped grade school science completely. But what we see here, obviously, is are the rays from the sun, and we have the penumbral shadow and then the umbral shadow that crosses, and I've tried to draw it in. I did all this in Photoshop, approximately where the path of this eclipse is. And you can appreciate that if the moon is located here, and obviously this is not nearly to scale, but if the moon is located here with respect to Earth, that is at this distance from Earth in its elliptical orbit, then the cone of the umbral shadow, in fact, can reach Earth and touch it, and you can see a total eclipse. If, on the other hand, an eclipse occurs, new moon occurs when the moon is further away toward apogee, further away in its orbit, then it's not quite large enough to cover the full disk of the sun, and the umbral shadow falls short of Earth, and therefore we don't see a total eclipse, we see an annular eclipse, and I think that everybody is familiar with that. We also are very familiar with the fact that the moon does not orbit around planet Earth in exactly the same plane as Earth goes around the sun. Rather, it's tilted about 5 degrees, actually just a little bit more than 5 degrees. And so in the vast majority of occasions when it's new moon, the moon passes either to the north or to the south of the sun and misses the sun completely. It is only twice a year, so-called eclipse seasons, 6 months apart, and they revolve around the calendar, that an eclipse of the sun can take place. Fortunately, they do happen every year. Every year there are at least 2 eclipses of the sun that can be seen from at least some place on Earth's surface, and there can be up to 7. So between 2 and 7 every year. And of course we know and we appreciate the difference between a total eclipse and an annular eclipse. Annular from the Latin term annulus, meaning ring, a ring eclipse, and a partial eclipse, which of course precedes both an annular and a total eclipse. So we are familiar also, and I'm sure people have seen the paths. These are the paths of eclipses. The total eclipses in blue, the annular eclipses in red. There are slightly more annular eclipses than there are total eclipses. In the northern hemisphere, there is a greater proportion of total eclipses, and one of the reasons for that is that, of course, in the northern hemisphere is summer. The axis of Earth's rotation is tilted toward the sun. That's also when we're nearest aphelion. We're furthest away from the sun, so the sun appears slightly smaller in the sky than it does actually during our winter. And therefore, there's a greater incidence in the northern hemisphere of total eclipses, and it's the reverse in the southern hemisphere. Interestingly, I think you may know this, but it's one fact that I learned to my horror early on in my astronomical career. You're probably aware of the fact that the moon is gradually moving further away from planet Earth, and that is because of tidal friction. The moon's effect and the tides are slowing down Earth's rotation in order to maintain the totality of what's called angular momentum in the Earth-Moon system. As the Earth slows its rotation, which is why we have to add leap seconds every few years, the moon is moving slowly away. And in far future epochs, the moon will never appear large enough in the sky to cover the sun. We are now living, therefore, in an era where we get this phenomenon of the total eclipse that just barely covers the sun, and it's an epoch that will not last for all that long. So these are the eclipse paths for this period of time. And one of the things that this really illustrates, and we have, of course, the path of the 2017 eclipse. We also have the path of the 2024 eclipse, which I'll talk about just very briefly for about 30 seconds at the end. One of the things you'll notice about this one is, well, there are several things we'll talk about. One is it passes right over Niagara Falls and just barely misses Toronto. Second is that it's a wider path than this, which means that moon is closer, moon is bigger, the length of totality is longer in 2024 than it will be at this eclipse. And for those people who are right here in southern Illinois, they may get to see 2 eclipses within 7 years. But the other thing I wanted to point out is this curve and this curve. And you can see that these two curves are very, very close, 2024 and 2006. And how many years apart are they? Well, approximately 18 years. And that, of course, is the Saros. And that is the approximately 18-year cycle after which eclipses of the sun, whether partial, total, or annular, repeat themselves almost exactly, except for 1/3 of Earth's rotation. And so every 18 years, this was in 2006, in 2024, this will be the eclipse, almost identical, almost same length of totality, almost same path width, same latitude, same starting point, and so on in latitude, but 1/3 of a globe around. And so the next one, 18 years after that, will be out here in the Pacific Ocean. So this is actually a really good demonstration of that. And we get the same thing here with these eclipses, one Saros cycle apart. Okay. So when you take a look at 1,000 years of solar eclipses, this was an observation that Randy Atwood had made last Friday. You can actually see barely the outline here of North America and the Great Lakes. These poor people here see nothing in 1,000 years, which is really a shame. But, you know, that's what cars are for, or Uber. So this, of course, is the path of this eclipse, starting out of the Pacific Ocean. All of this area will see a partial eclipse, and therefore a partial eclipse just before sunset in the in Western Africa, which I think would be an interesting thing to see, but I'm sure not going there. Now, the greatest duration of the eclipse of totality, 2 minutes 40.2 seconds, is located here. The greatest eclipse, they're not absolutely identical for reasons that I'm not going to get into right now, but this really is in western Kentucky, right in this area. I got to say, though, not a huge number of people who are knowledgeable are going to go there, and we'll talk about why. So this is kind of interesting, and this shows here you can see the universal time, and that, of course, is the umbral shadow. But we can see here the penumbral shadow and the umbral shadow crossing the planet, and then the sunset line there. I really like this a lot. You see, so right now over North America, everybody sees at least a partial eclipse. Okay, so then these are the states, obviously, that the shadow passes through, and all right, so through all of these, and you can see it passes right through very populated areas, starting in Oregon, and that's where Ralph Chu is going to be going. He tells me he's going to be in Salem, which is right there. That's the capital, I believe. Really, really pretty city, and you'll probably be just driving south a little bit, I guess, to the path of totality. Here, 2 minutes, 1 second of totality, so markedly less than further east, but there are very good reasons for going here, as Ralph may talk about. And then through Idaho, and we see Idaho Falls, one of the large cities there, and Boise, and then into Wyoming. A lot of Toronto Centre people, including Randy Atwood, are going to be here. The Teton Mountains, there is Jackson, and Jackson Hole is in this area. Here, the length of totality is increased to 2 minutes, 22 seconds. Yellowstone Park, which will see a large partial eclipse. There was an article that I read last week in one of the local newspapers saying Wyoming, how is it going to cope? Because it's expected, the state officials expect that the population of the state will double for 1 day. And there are very few airports, and so they got all these hotshot people who have their own private planes who for a long time have been trying to get landing rights on Eclipse Day to see it, and so they're running into an awful lot of problems. Then Nebraska, and so we have Lincoln, Nebraska, Omaha, which is outside the path, and then Grand Island here, and that's where I'm going to be for a bunch of reasons that I'll talk about, and one of them is this, the interstate, if it's cloudy. So we'll talk about that as well later, and a lot of RASC people are going to be there, including a bunch from Halifax. So that's where I'm going to be located. And then through Kansas, just barely cutting through Kansas here. Missouri, now this is really interesting. There's St. Louis. So if you live in the southern suburbs, you will see a total eclipse. However, if you're right downtown and you're right where the Gateway Arch is, you'll see a great partial eclipse, but you won't see totality. So that's St. Louis. And then Kansas City, same thing. The southern limit here passes right through Kansas City. And there are two Kansas cities, as you know, one in Kansas, one in Missouri. Then it crosses just the southern part of Illinois. So a lot of people will be driving from Chicago, I expect. And then into Kentucky, and this is where we get the greatest length of the eclipse. But weather prospects may be iffy, and we'll talk about that. Crossing Nashville and Louisville here. And then also Tennessee, into Georgia, missing Atlanta, but it's a very short drive there. And then finally, just a touch of North Carolina, and then mainly through South Carolina, where you have Charleston here, and then off into the Atlantic Ocean, where about half an hour later, the shadow finally leaves Earth's surface. So for those of you who are interested in finding out some more about this, a lot of you may have all of this stuff. There is the Great American Eclipse website that was set up, I think, about a year ago, and it really is a good website. It has all sorts of stuff from maps and history and everything that you want to know. So I really like that one a lot. Then the NASA website, which is very good. There's a specific one for this particular eclipse, but I like this one, and one of the reasons is this. This is the interactive map, and it's a really, really great map. It is zoomable, and one of the great things is that you can click on any location, and it will disclose the following information. So from where I'm going to be. All right, so this is Nebraska, Grand Island. In fact, right there, which is the KOA campground where we're going to be staying, right there, we have all of the information. The precise time in universal time, easily convertible to central time of these phases, the start of the eclipse, maximum eclipse, the precise altitude of the sun and the azimuth of the sun. I'm going to come back to that because that's going to be very important. The precise length of totality. So you can do that for any location where you're going to be, and it will give you all of that information. Now, as I say, all right, so this is what you get in Toronto. All right, you get a 76% eclipse. Now, you see magnitude and obscuration. Magnitude is the fraction or proportion of the diameter of the sun that is covered. Obscuration is the amount of the total area of the sun that is covered. And so it's a pretty nice eclipse happening, and here are the times. So it's approximately then a 2-hour, 40-minute eclipse in total, with the sun quite far up west, just west of due south. So that is Toronto. There are great publications as well. This is by far the best one, not surprisingly, by our good friend Fred Espenak. I met Fred back in the 1970s. We've seen eclipses together. He is probably the world's greatest eclipse predictor, as I think you all know. This book is available. It's an excellent book. It's also available online in PDF format. I've got both of them. It's really quite terrific. And then the Road Atlas. Now, unfortunately, I got this screen capture yesterday, temporarily out of stock. It is going to be coming back to Sky Publishing. And you can download it, however, in PDF format, and there are other sites that have this book, and it's fantastic. It has very, very large-scale maps of every square kilometer of the path through all of the states. It's a terrific book. And then Jay Anderson's website, dealing with weather and various other things associated with the eclipse, and this is his website, which is really a very good one. So let's just talk about that for a bit. And Jay Anderson really is the guru for weather and eclipses. And these are two really, really interesting and I think important maps. So this shows the average cloud cover for the date of the eclipse for several years, averaging several years in the past, for two different times, 10:30 local time and 13:30 local time, 3 hours later. And if you can take a look at the legend over here, you can see blue is clear, and then yellow and red is not clear. So a few general comments about this. It's immediately obvious that there is pretty much a line that goes, well, actually just west of the Mississippi River runs up through here, west of the Mississippi River, and it's very obvious that the western states are markedly better than the eastern states. I don't think anybody is probably surprised at that. So that explains right away why so many people are going here to Salem, Oregon, Ralph. All right, you can see that blue there, except maybe out on the ocean, or to Nebraska. That looks pretty good. And then, of course, Wyoming, Idaho's here, and Wyoming. So, you know, these are where our RSC members are going, and it's no accident at all. Into the east, oh yeah, it's easier to get to from here, but it's a lot riskier. Now, there are a couple, and all right, so that's the first thing. The second thing is, if you take a look at the change in the 3 hours, you see the cloud here, and then the cloud here, the cloud here, and the cloud here. It is markedly cloudier in the afternoon. Veteran eclipse goers know this from experience, sometimes bitter, sometimes not. Why? Particularly, and this is for summer eclipses, and not so much for winter eclipses, but for summer eclipses, what happens, and I'm no meteorologist, but I know enough to cry when I'm clouded out. With the, what is it called, adiabatic warming, the warming during the daytime, it warms the ground. It causes, therefore, updrafts. The water vapor in the atmosphere rises and then suddenly cools as it rises higher. It then cools, forming cloud. We discovered this in Mexico in 1991. All right, and so what that means is that in the afternoon, you tend to get more cloud than in the morning. And that's why more tornadoes, for example, happen in the afternoon, and why thunderstorms happen in the afternoon in preference to in the morning. Now, what does that mean? Well, if you think about it in this way, right around here is where is noon, local time, where the sun's almost on the meridian. This is morning for the eclipse, where the sun way out here is going to be just above the eastern horizon, and it's an early morning eclipse. As the shadow passes in this direction, it gets later and later and later until it's an afternoon eclipse over here and then an evening eclipse out here. And so for those in the eastern states, it is an afternoon eclipse, which will take place at exactly the time that cumulus clouds are forming in the atmosphere. That is why eclipse goers, if they can, always want to be in the morning half of the path of totality. Always. If you can do it. Now, sometimes it's kind of, you know, out at sea, and so you can't. But so these, I'm spending some time on these maps because I really think that they tell a very, very important story for anybody who is interested in going to see the eclipse and maybe hasn't yet made plans or has made plans and better cancel them and go someplace else. Okay. All right. Yes, I think this actually is it. What this shows then is for the same times, 1030 in red, 130 in blue, the mean fractional cloud amount going all the way from where the shadow hits North America to where it goes off North America into the Atlantic Ocean for all of this. And what we can see here very clearly is that the greatest chance of clear skies is here in the Columbia Basin. Cascade Mountains not so much, but right here in the Columbia Basin. It increases over the mountains here and then decreases in Idaho, increases again over the mountains, and then we get into Casper, and this is where Jackson's going to be. So the RASC expedition, there were a lot of people going to Jackson, Wyoming. That's a very, very good location, and especially in the morning. You can see the difference in the cloud cover. Now, where we're going to be right here, there's not that much difference. So these three are really the areas of the best chance of clear weather. And Ralph is going to be there, Randy Atwood's going to be there, and Michael Watson's going to be there. Although I may end up going just a little bit further, who knows, depending on eclipse day. So this is a really, really important one, and I think it really tells an exceedingly important story for this particular eclipse. And you can find this online. Okay, so. And I think, so a couple of things. First of all, how many people use the clear sky chart? Right? How many people sometimes curse the clear sky chart? For example, if you drive up to Torrance Barrens or Algonquin Park based on the clear sky chart and are disappointed. However, it's one of the best resources available, and it is available in the US. As some of you know, maybe some of you don't. So here is the clear sky chart for the Campground of America spot where Helen and I are going to be staying with a whole bunch of other people. And this just happens to be I grabbed this on Tuesday. And so you can use that and you can get it for any location. And the great thing about it is we're going to be right here and you can get it for all of these locations very easily on the Clear Sky Chart website. So, and that's for all of North America. So, and the predictions are generally for the level of cloud cover and transparency for 48 hours ahead of time, which is going to be plenty, because decisions are made on eclipse morning or the afternoon before the eclipse, the Sunday afternoon before the eclipse. And so this really is a very quick and pretty good as it gets, source for information for cloud cover. Now, the other thing is, thank you, Dwight D. Eisenhower, who created the interstate highway system in the 1950s. One of the things about this area all through here is that it is really, really well served by interstate highways. And west of the Mississippi, they are not crowded. We have driven through on all of these, through all of this area many, many times. And you can see why so many people are headed to Nebraska, because Grand Island is there. And for a whole bunch of distance, about, as the Americans say, 400 miles through here, the interstate is in the path of totality. So if you need to move east or west, there are highways in here as well, but a quick jog up to Omaha and down, and particularly west on eclipse morning or late afternoon on the Sunday, you absolutely can do that. So that's the interstate system. And when you get into Wyoming, it's way more difficult. Jackson is over here. There is no interstate anywhere close. And generally, the main highway runs north-south. North-south. There is one that runs east-west from Yellowstone Park, which we've been on as well. But you know, I'm hoping that they get clear skies, because it's going to be difficult to move in Jackson, if only for the bison. So, okay, let's move on. Let's talk a little bit about equipment. I'm not going to talk an awful lot about this because this is Ralph's area, but I just want to draw everybody's attention to that to the RESC that has a shop that has eclipse glasses as well. And I'm really not going to say much more than that. But this is something that I think is really, really important. Yeah, people can have telescopes and so on, but I think that most people, whether veteran eclipse observers or neophytes, appreciate that one of the best views that you can get is through binoculars for a whole bunch of reasons. You get a wide vista of this beautiful black hole in the sky with the corona. You can see the bright planets around, which we'll talk about shortly. And so binoculars really are the way to go. And particularly, of course, if you're flying someplace and you can't take a big rig. So that's something to consider. And so here are a couple of suggestions. Don't make them too big. I don't like using magnification greater than 8 power. 8 power is something that I can hold steady, whether or not I've been into the wine. And you know, you get up to a 10, well, that's okay, but 12 or 15, you know, your binoculars are shaking around and you can't keep the image steady. So I really do suggest that you think about making it lower magnification. Experienced astronomers using equipment always go for low magnification, always. You get much better views. And you also don't want them to be all that heavy. So one of the things I'm showing here is this, and I'm going to be talking about this again. An aspect of this eclipse that may not be obvious, but is extremely important, is how high the sun is going to be in the sky. It is going to be in the central part of the eclipse from Wyoming to Tennessee, 60 degrees high. Right now, I'm looking up at an elevation of 60 degrees. You cannot conveniently watch an eclipse standing up, looking 60 degrees up like that. You can't do it. It's not comfortable. And so what I suggest is this. Now, not on our parking pad, but when you get to the eclipse, and even here for partial phases, if this is where you're going to watch it from, get on your back, get a pillow, and with your binoculars, and observe it that way, and you'll be way, way more comfortable. Now, that's but make sure that you do it right. Now, that may be a very effective solar filter of a kind that Ralph may not be talking about or may recommend. And also, please, you have to make sure that you're doing, you know, all right, So look in the right direction. It should be easy to find the sun if the weather is good. If you're interested in photography, and a lot of people are, you don't need fancy equipment. And this is one of the things that I try to talk about every time I do an astrophotography talk. Yeah, you can have lots of fancy equipment, and I guess I've got some, but anybody with any camera can take a reasonable eclipse photograph, no matter the lens you have, no matter the camera, including a point and shoot camera. I'm going to come to that, but it absolutely is true. But if you're going to use a tripod, make it a good one, a really good one, and not a flimsy one. So many of them are really crap. This is what I use. And this is an expensive tripod. It's about $1,200 now, but it's incredibly rock steady. It also holds my portable tracking mount. If any of you have seen my pictures from Australia using a little portable tracking mount, which I think are pretty decent, it was on this tripod. All right. Now, so you got to spend $400 for a tripod. You can get a $79 tripod, and that's what you can use to snap into over your knee. You need to spend some money to get a decent one if you want really decent photographs. Just going to mention this, and this is what I use for my photographs. How many people know Kendrick? Right. Jim Kendrick is a great guy. He's a terrific guy. He's had some health problems, but he is recovering. I like him a whole hell of a lot. He sells batteries as well. I've got 3 of his very large batteries that I run my rig on all night long. But he also produces filters that use the pliable Bader solar filter. Very good, and kind of surprising to people who think about thick glass filters that are supposed to work very well, and they do. But I like these a lot. The one difference about these is, and this is what I like. You have these set screws. If you're going to buy these, and they're promising they will deliver them now, but order them now. I've got 3, one for my refractor, and then 2 4-inch ones for 2 smaller refractors that I'm going to be taking. You can get them now. Make sure that you order them for the right dimensions. It's really easy to measure them, and you'll see here is these are 127 for the large one. This is the one that I use for my large 6-inch refractor. $127. It's not bad at all. Down to small ones, so they are absolutely affordable. The interesting thing about it is that with these, and this sometimes startles people, you get the true color of the sun, but not what we think it is. So this is a photograph that I did. Can anybody tell me what day I took this on? What is shown here? Transit of Mercury. There's Mercury. Okay, so this is a photograph made through the Kendrick solar filter last May, 11 months ago. You can see, it does a pretty nice job on that sunspot with both the umbra and the penumbra, and another one over here. And what you can see is, and this is one of the things I'm going to suggest as well, that you practice, because if you notice, you can see some other little sunspots here as well, and the sun actually wasn't all that active, but you can see all of that with this filter, really nice filter. But also, you see how the edge is a little darker than the center? Well, that, of course, is true. That is a true effect. One of the things that's important here is this. If you have the right exposure, then your exposure will, in fact, show the edge darkening of the sun, which is a real phenomenon. And so what you want to do in practicing ahead of time, and I don't mean the day before the eclipse, I mean 3 months before the eclipse, or 2 months before the eclipse, or both of them, is take a whole series of photographs of the sun when it's up really high with the ISO setting that you want, and try different shutter speeds until the result that you get isn't completely burned in with a solid white disk, but you actually do see some darkening at the edge. If you see that, that's the right exposure that you can then use on eclipse day as well. Okay, so that's what I use. Now, back in the old days, this was in, boy, shorts were short back then. This was in Papua New Guinea in 1984, where we went to see a 53-second total eclipse of the sun. And we did that. We went that far to see such a short one because the previous May, we had seen the beaded annular eclipse in North America. And for the first time, this is a really interesting story. For the first time at such an event, we actually saw the corona. I'd read accounts of this in Sky and Telescope going back 18 years earlier to the one that was seen in Greece, where they had wondered whether they might possibly see corona. And the reports I read were no, we looked at central eclipse and didn't see them. This was Dennis DeChico, for example. And I concluded they're looking at the wrong time. They were looking at the middle of the eclipse. And I concluded, no, that's not the time to look. You look 30 seconds before on one side of the sun, 30 seconds after on the other side. I did that. I saw it in May 1984. No one else had seen it or reported seeing it at a Beta eclipse before that time. So having seen the corona and actually photographed it at that time, we thought, let's try for Papua New Guinea. Why? Because no one in history to that point had ever seen the corona at 2 successive solar eclipses. Because there cannot be 2 total solar eclipses in succession, right? There cannot be. And so having seen the corona at that one, we then went to Papua New Guinea and did what no one had done before. So, so that was, all right, so that was in Papua New Guinea, the morning of the eclipse. That's Bob May, a Toronto Centre member from years ago. And this is Randy Atwood's setup in 1988. Helen and I were there as well in the Philippines, in Mindanao, as you can see from here, very close to the equator. And that was his setup. So, but this is older stuff and a somewhat more modern setup. So this is one of the rigs that I'm going to be taking. This is my smaller mount that is going to be used for visual work. I'm actually going to put the big scope on an astrophysics mount. But this mount is about $2,000. Not cheap, but it's a really nice mount, little Skywatcher, altazimuth, and equatorial mount that I use for people who've seen my lunar photographs. This is the only mount that I use for all of my lunar photographs, and it's a really nice mount, and it's quite portable. And what I've done here is I have mounted a camera lens and body on top of, on the rings on top of, and obviously pointing in the same direction as the telescope. And then looking at it from the other end, you got obviously your declination axis here. You got a Nikon camera mounted directly on the telescope. So in effect, this telescope becomes a 1200 millimeter f8 telephoto lens. And then on here I have a ball head, and I just do the drilling and tapping myself with a 3/8 inch bolt that I just cut the head off, screw it in, and then put, whoop, sorry, go backwards, and then put a really good ball head. I buy these in the US, and I really like it a lot because you can just move it around. I hate these 3 axes ones. I don't think they're any good at all. A ball head is the way to go, and that's what I use for all of my wide field astro photographs. And the camera here. Now, there's one thing I want to point out for those of you who may be seriously interested in some photography using an equatorial mount. What is important is to orient the camera in the right way. I think we're all familiar with the fact that when you have the eclipsed sun, you've seen the photographs of the corona, you see polar brushes coming off the north and south poles of the sun, and then what tends to happen is that the bulge of the corona, depending on whether it's near solar maximum or minimum, is east-west. And generally people like their photographs to be oriented that way. So the polar brushes are upwards and downwards on the frame, and the bulge is out to the sides on a 35 millimeter frame, for example. The only way to do that is to make sure that your camera is oriented east-west and not askew or not north-south. And remember, you can't tell if you're early in the eclipse path, north may be that way in the sky or that way in the sky. And so the way to do it is very, very easy. When you set up your mount is to have it, and I haven't done it quite here, but you can see that the declination axis, it's turned so the declination axis is almost parallel with the ground. So you set it up, you turn your telescope to the south, and then you turn it so that the declination axis rises, and as soon as it's at 180 degrees, your telescope is pointed due south, and you can use a little inclinometer. You can buy a Canadian Tire for $6 to get it due south, and then you simply have your camera body here oriented exactly the same way as your declination axis using an inclinometer. It's really easy, right? And that's how you get north-south, just like that. Very easy. Now, you can also use Photoshop to rotate it all afterwards if you want. Okay, so another view, and that's with a 200 millimeter lens. Okay, so that's one of the things that I'm going to be doing. Now, for those of you who are going to be using German equatorial mounts, This is something that's really, really important. How many people here have ever had their telescope on a German equatorial mount actually hit the mount? Anybody? All right, well, one person. It happens. And this is going to be really important for this eclipse and for anybody who may be streaming this and listening to it. So the azimuth of the sun, azimuth being, of course, the direction around the horizon. So due east is 90 degrees, due south is 180 degrees, due west is 270 degrees, and due north is 0 or 360 degrees. And therefore, we're thinking about due south 180 degrees. So what we have here, and it took a little while, as you'll appreciate, it did take a while to plot all of this. So here are your states and your towns. So if you are on the eclipse path here, here is the line where the sun will have an azimuth of 150 degrees, and that's the direction that the sun will be in. So, for example, let's suppose that this is south and you have your telescope set up. All right, at mid-eclipse, the sun's going to be 30 degrees east of due south and 60 degrees high in the sky at 150 degrees azimuth. As you move east, obviously, the Earth is rotating and the sun is moving further to the south until eventually it gets to the meridian. So 160 degrees azimuth right there. Very close to where we're going to be. Where we're going to be is about 162 degrees. 170 degrees, and then due south 180 degrees. And you see greatest eclipses here, and the sun will be 109 degrees, so about 195 degrees there. Now this is important for people who are using German equatorial mounts and are going to be setting up their mounts, because if you're, if you are here in the path, and I'm going to illustrate this now, your telescope needs to be on the west side of the mount pointing east, and you need to know that beforehand. If you're anywhere in this part, it needs to be on the other side, on the east side pointing west. And you got to pay attention to this because, of course, the eclipse takes 3 hours. In 3 hours, your mount's going to move through 45 degrees. And you need to know where it is and where the azimuth, where the sun's azimuth at mid-eclipse, because you sure as hell don't want to be moving your telescope from one side to the other with 25 seconds to go before totality. So, okay, so photographing. How many people here have digital single-lens reflex cameras? All right, a bunch of people. You'll be familiar with the fact that there are basically two different kinds. These are DSLRs, not point-and-shoot cameras. So-called full-frame cameras, 35mm cameras, and there aren't many of those, and so-called crop-frame cameras, which use DX lenses as opposed to FX lenses. Way more people, I would say that the ratio of crop-frame cameras that are sold to full-frame cameras is probably about 100 to 1. Full-frame cameras are expensive. You know, they're in the neighborhood of between $3,000 and $5,000 just for a camera body. But what's really important to appreciate is that this is a full-frame camera. This is the relative size of the sensor on a full-frame camera. And this is for Canon and then Pentax and Nikon, this is the size of a crop frame sensor. And what that means is that when you're projecting the image of the sky onto these sensors, a full-frame camera captures a way wider area of the sky than the crop frame sensor does. And what that means, therefore, is that for any particular focal length of lens, say 135mm lens, 135mm is how it appears on a full-frame lens. If you are using a crop frame lens, you have to multiply the focal length of your lens by this amount. And for a crop frame camera, it's 1.5. Another way of putting it is, if you're talking about a 200mm lens, it behaves like a 200mm lens on a full-frame camera. It behaves like a 300mm lens, 200 times 1.5 on a crop frame camera. And it's really important to understand that. I'm going to illustrate that with some graphics showing what these cameras will actually do on the sky. So this is really important to appreciate the kind of camera that you have. Okay. All right. So if this represents then a full frame border, and it's you know, for example, cameras that I use, Nikon D3, Nikon D810, the Canon EOS cameras, and then this is the crop frame border of most cameras. They're very close to 2/3 the size in both dimensions for almost all of them. So that's what you get. Now, let's take a look, and this was startling to me the first time I appreciated it. The moon and the sun are really small in the sky. We don't necessarily think of them that way because they obviously attract our attention. But boy, they're small, approximately half a degree in diameter, which means that if you put a whole bunch of moons or suns, because they're almost exactly the same apparent size of the sky, touching each other all the way across the sky from one horizon to another, that's 180 degrees. You could get 360 of them across the sky. That's how small the moon and the sun actually are. And so with a standard 50 millimeter lens, that's the size that you actually get. So you'll see what that would look like in your crop frame camera and in your full frame camera. A 50 millimeter lens. Use a wide angle lens, a typical 135 millimeter, just moderate wide angle. That's the size. A much wider, extreme wide angle lens, and a lot of people have these. I love mine, use it all the time, 24 millimeter lens. You can see how small it is. And therefore, this explains, you can see really graphically here, why people need telephoto lenses to get any kind of detail in the corona and, for example, Bailey's beads or prominences. So 135 millimeter lens is a very standard focal length for a short telephoto lens. A lot of people have 200s. That's the size you will get with a 200 millimeter lens. And a lot of people have those. A lot of people will be using that kind of lens at this eclipse. You can now empty your bank account and go higher than that. So, for example, a 500 millimeter lens, you're starting to get some pretty nice image scale there. But now you really need to be thinking about a motor-driven mount. 750 millimeter, 1200. So that's the size that I get using my 6-inch refractor. So you can get inner and middle corona, but not so much the outer corona. And then if you're using a 1600 millimeter or something like a Celestron 10 or 12 or something like that, you get with 2000 millimeters, but hardly anybody is going to do that. So then this is important as well. What is the correct exposure? Well, in my view, there actually is no such thing as a correct exposure. A lot of it is psychological. A lot of it depends on some of these factors as well. I don't think that the altitude of the sun and moon will be all that important at this eclipse because the sun's going to be fairly high for the entire eclipse path across North America. So yeah, I don't think we need to worry about that. But the psychological effect, I discovered this a long, long time ago. If you have a very small image size from a 50 millimeter, 135, even 200 millimeter lens, you've got a frame that is almost entirely jet black with this small corona in the middle. Psychologically, it looks like it's dim. Whereas if you were shooting the same thing with a 1200 millimeter lens at the same exposure and focal ratio, it'd look much brighter because you got way more of the corona filling up the frame and less black. And what I discovered therefore, and this again is psychological, but I think it's real, is that for a shorter focal length lens, in order to make a pleasing image that actually arrests your attention, you need a longer exposure of between 2 and 4 times. So you might just want to think about that. So one of the best ones, Alan Dyer, maybe Canada's best astrophotographer, certainly one of the top half dozen. And again, this is for a lens shooting at f8. You can get these online. These are fairly well known. I did want to say one thing, and for those of you who know me, I've talked about this before. A lens shooting at f8. Lenses, of course, really good lenses and fast lenses and expensive lenses can open up right to f1.4. And they can be stopped down to f16, sometimes for longer focal length lenses, f22 and f32. And that's fine. However, repeatedly, it has been demonstrated that almost all photographic lenses work best when they shoot at a focal ratio, an f-stop, if you will, of between f8 and f11. In that range, f8 to f11, you get the best resolution possible. The resolution really gets lower when you open it up to f5.6 and f4 and so on. For those of you who know my astrophotos, you know that I use f1.4 lenses, but I always stop them down to f4, f4.5, sometimes f5.6 to get rid of the vignetting, to get rid of and eliminate all of the aberrations. The closer you can get to f8 and f11 in that range, the sharper your photographs are going to be. And therefore, and remember, there's not a problem with the amount of light at a solar eclipse. There just isn't, as compared with deep sky photography. So I really do suggest that you think very carefully about that and use f8 or f11 or something like that. And so for an f8 lens, what you can see here is for the diamond ring and the prominences, you're shooting, even at ISO 100, really, really short exposures, really short exposures. And for intercorona, even a 60th of a second. And so even with a modest camera on a tripod, certainly, but you don't have to have a motor drive in order to be able to take sharp photographs using exposures like this. Another one is Fred Aspanax. It's much the same effect. You don't have to worry about it. You can get this. It's on his Mr. Eclipse website if you're interested. And most of the charts use the same general exposures. I'm probably going to be shooting mine at, depending on how I feel in the day, ISO 100 or 200. Certainly not any faster than 200 because you just don't need it at all. And it can start to introduce some grain. Okay, so again, this is something that is really important. This was very carefully measured last week when I did this photograph. The lens here is pointed exactly 60 degrees up. So it's really far up. And one of the things then you have to think about, and you want to think about it ahead of time, is how am I going to frame and focus? Is it sort of going to be this? Really important to think about, unless you have a camera that has a flip screen, right? And some do, but DSLRs tend not to have that. So you got to think about that and practice it ahead of time. And what that means probably is getting your tripod up fairly high. One of the things I'm thinking of doing with my big astrophysics map is I'm going to take some big 6-inch blocks of wood to put under it to get it up high enough so that I can have my 6-inch refractor and it's going to be at a convenient eye level. 60 degrees is a really important thing to appreciate for this eclipse. We've seen lots of eclipses at low altitude. In February in Gimli, Manitoba, the sun was about 22 degrees high. In Papua New Guinea, it was 24 degrees high. Those make great eclipses because you can get all the foreground and really nice photography and all of that. But if you can get a high eclipse, you want to. And in Mexico, in July 1991, the sun was 80 degrees high, almost in the zenith. And that poses some problems. You just have to be aware of it, think about it, and plan for it ahead of time. One of the things you can do is you can use a right-angle viewfinder, which is shown here. They're not inexpensive, but boy, they're really good, and your chiropractor will appreciate that you've got one. I actually have to buy one more because I'm going to have 2 cameras on the go on the tripod. So anyway, something to think about. Now, just before I then go into what you can photograph of this eclipse, I think that this is an interesting one. And here we have the sun just slightly east of due south. And what this means is this is what the sky will look like in Nebraska and Wyoming before local noon. So kind of middle to western Nebraska. I'm going to be talking about this. Venus actually, isn't that big, but it shows how bright it is. And obviously Venus is always the brightest object in the sky ever after the sun and moon. Jupiter down here, not very far above the horizon. We have faint Mercury here and Mars. We'll be talking about this a little bit more, and then various of the stars. So these are things that are that may very well be visible during the eclipse. So we have here then the sun on the ecliptic, where Mercury, and these are all to scale. So where Mercury is going to be. And this then, as I say here, this can be shot with a full frame camera using a 35mm lens or 24 on a crop frame camera. And so just a few things. First of all, obviously, Venus is bright. Venus has gone through inferior conjunction. It's now moving out and it's going to be heading towards Superior Conjunction. So it's actually going to be a fairly big gibbous Venus, and therefore only about half the brightness that it is when it gets to its brightest, which is at about minus 4.7. It's still going to be very bright. You can always see Venus in a clear sky a good 15 minutes before totality and the same length afterwards. So that's going to be really easy. Mars is quite faint because Mars is obviously on the other side of the sun, or almost on directly the other side of the sun. And Mercury also is going to be really quite faint. I don't think there's probably much of a chance of seeing Mercury at all. This is really intriguing. And one of the things I do want to mention about Mars, back in June of 1983, Mars was very, very close to the sun, way closer than it's going to be this time. And obviously, therefore, on exactly the other side of the sun as well, and quite faint. We easily, in binoculars, saw Mars shining through the corona. It was that close. It was just a remarkable, absolutely remarkable sight. So I have no doubt that Mars will be visible, maybe not necessarily to the unaided eye, but certainly in binoculars and absolutely in a telescope, if you want to move your scope that far away, which you probably don't. Okay, so that's how close Regulus is going to be. Regulus, therefore, is going to be many times brighter than Mars was in 1983 when we saw it clearly, many times brighter, and that's going to be a really remarkable view, a really remarkable view. So that's what you can use, photograph using a standard lens. All right, so that's how close it's going to be. If you got a 1,000mm lens kicking around on a full frame camera or a 500 on a crop frame camera, that's what you're going to be able to get. And there's no doubt a lot of people are going to be trying to photograph that scene, I can tell you. That's going to be pretty interesting to see. Okay, this is just one other thing that I want to show. Remember I was talking about orienting it so that your camera's due east-west. Well, not exactly, because here is the ecliptic. Obviously, celestial north is up here, as you can see. However, ecliptic north, all right, where the north pole of the sun and moon are going to be, is that far off, okay? And therefore, what I'm going to be doing, and if you're sort of at this level of technical stuff, what I'm going to be doing is I am going to be leveling my camera at 180 degrees, and then using the inclinometer, I'm going to tilt it 20.5 degrees that way so that it's going to be exactly not sky north, but moon and sun north, which is what I want to do. So just a little thing that I would have been thinking about for the last decade, getting ready for this eclipse. Okay, so some of these are really old ones, but I did want to show Randy's the executive director of the RASC, and this goes back, I believe, to 1988. Another nice one by Randy, and I believe that this was a Turkey eclipse, 2006. Roy Bishop took one many, many years ago of the diamond ring. I think this actually could be 1970. I've never asked him, but of course the eclipse went just about over his house out in the Maritimes. And then a very, very wide-angle view. You got to use almost a fisheye lens, however, to get this kind of view with the sun so high for this eclipse. Now, these are really interesting photographs. I personally don't like them. Wendy Carlos is one of the great eclipse photographers ever. These are highly manipulated photographs that do show some of the great structure in the corona. Actually, yeah, let's stay on this for just a moment. The problem with this kind of image, you can see it all over the internet, is this looks absolutely nothing like what an eclipse looks like to the naked eye. Nothing at all. Why do I say that, and what do I mean by that? You see the darkness of the moon? The darkness of the moon is the same as the darkness of the sky located away from the corona. So the sky out here should actually be that dark. But through photo processing, you can get all of this detail, but it doesn't look anything like it actually looks to the unaided eye. All right. So the blackness of the moon is going to be exactly the same as the blackness of the sky or the brightness of the sky 5 degrees away, exactly the same. Right? And that's what I think people don't appreciate when they see a photograph such as this. Okay. Uh-oh. What's happened here? Okay. All right. So Fred Espenak, always he's one of the great eclipse photographers as well. This is a little bit more what you see. You see corona out here. Sometimes actually you can see corona out to here in binoculars. But that's you see that the color of the sky and the moon are actually the same. They absolutely are. Come on. Okay, for some reason. Okay. All right. So back in 1999 in France, just north of Paris, we had some scudding cloud just before totality. This is taken through a 5-inch refractor on the side of one of the autoroutes north of Paris. This was a great eclipse. Helen was with me. Randy Atwood and his wife Betty Robinson were there. There's a very interesting story about that. And so you can see here the pink photosphere, a fully detached prominence, which was remarkable. I don't think we've ever seen an eclipse photograph with something like that. And then middle corona. And so that was a pretty great eclipse, 1999.
Michael,
Yes.
that's the same one in the Saros series as this one.
It is exactly. This was the predecessor eclipse of the Saros cycle. And what that therefore means is that the path of that eclipse was almost exactly the same as this one, but half a globe away, crossing the channel in France and then off into the rest of Europe. Yeah. Running into problems with this. I don't know why. Okay. Now, I think you can also appreciate that Earthshine is at its strongest at new moon. And therefore, one would expect that you can see it. Well, not with the corona there because the order of magnitude difference is so great. However, with a very long exposure, you can actually get Earthshine, and that's what our good friend Fred Espenak actually did. Don't bother looking for it. Don't waste your time, but you might be able to photograph it. And you want to be careful about too much technology. Yeah, go-to scopes are great, but don't be yelling at your scope to turn toward the eclipse. I'm an old point-and-shoot guy. Yeah, I use a good mount and all of that. But one of these people, well, 3 of them are seeing the eclipse, and 1 is just unhappy. I'm getting toward the end here. This may be, this is an unbelievably great book, and I stumbled actually on it not so long ago. It's only online. It is 290 pages just on photography, from the simple to the more complex. Really easy. Alan Dyer's website, Amazing Sky Photography, and he is an amazing sky photographer. That's where you can get it, and it's really worthwhile. Oh, man. Come on now. Okay. And not the morning of. These may seem like stupid things, but they're what drive people crazy and cause suicides, and if not marriage breakups, and telescopes in the garbage for the next week. It's not generally a good idea to run out of juice just at the diamond ring. So have extra ones, load them up beforehand, change them before. They seem like dumb things, but what happens, and I can tell you this, what happens is that your IQ goes down during the 30 seconds before the eclipse to about 1/3 of its normal level. And you absolutely go crazy. And so you want to practice it ahead of time. Someone will kill you if you use a flash. And people forget this all the time. or they don't care, or they think that somehow their flash is going to illuminate the corona 150 million kilometers away. So, and if you don't know how to disable it, then do one of two things. Put your camera in your bed under the mattress and leave it there, or put a piece of duct tape over the flash, right? But do that, please. If you try to fix it during totality, you will break something else too, okay? You just will not be able to do it at all. And this one is really, really, really important. Turn off autofocus. It will not work. Focus manually. Same with your aperture and ISO. You don't use auto. No camera is made to, you haven't seen a camera that's advertised as dedicated total solar eclipse camera, right? You have to do it all by yourself, all right? All by yourself. Now, this is an important one, and I think that this is really, really helpful. A lot of people who've seen eclipses say, well, the traditional wisdom is that the light level, the ambient light level, during totality, during a total eclipse, is about the same as a fully moonlit night. I don't think it is. I think that it's actually brighter during an eclipse for a couple of reasons. One is that you see sunset colors all around. And therefore, it's a lot brighter around the horizon than it is with a full moon high in the sky. But also, the corona is really bright. And so, for those two reasons, at the very least, it's never been my experience. And Ralph, I'd be interested in what you think about this. It's never been my experience, even at the long eclipse of 1983, when the moon was huge, that it actually was as dark as a fully moonlit night. But I don't know, what do you think?
No, definitely not.
Okay. All right. So. And so, if you can use your equipment and find it and not knock it over, and find your settings and all of that kind of stuff during a fully moonlit night, you will be fine during the total phase of the eclipse. All right, absolutely fine. But do practice ahead of time. And a fully moonlit night is absolutely the perfect time to do that. And so finally we get to 2024 as I wrap up, because that is going to be the next one for North Americans. And the last one in North America, certainly for my lifetime. This one is in April, and so the weather prospects will be quite different. And as you can see, the path here, this is at the ascending node. It actually, Ralph, is kind of interesting. It kind of mimics the eclipse path of the great March 7th, 1970 eclipse that crossed Mexico and then came right up the eastern seaboard and crossed Nova Scotia. And of course, that's the eclipse that Carly Simon's saying about as well. That particular eclipse is just a little further west. Now, the interesting thing about it is you see, there's the Science Center. And so what we will see here, what people who choose for some reason to stay here will see is a 99.5% eclipse. Maybe a little corona, but probably not. If you're in Buffalo, for some reason you want to go there, it's going to be almost directly on the center line. But although, people are all excited, oh, how great, we can get up. We can get up at 10 o'clock and sleep in and have brunch and then go see the eclipse. Okay, sure. But most of us are going to be here. That's where we're going. Why? The weather prospects are lousy. What's April like? Terrible. Yeah. And also, of course, here is the noon point. This is the afternoon, right? This is the morning. What was I talking about before? So frankly, for serious astronomers, it is completely irrelevant, except as a matter of geometric curiosity, that this path, I'm going the wrong direction. It's just a matter of curiosity that it happens to be passing over here, because everybody's going to be here, and it is, as you can imagine, a longer eclipse. And so, and the greatest eclipse, in fact, is in Mexico. So some people will certainly be going. And then, at the end, and that's what it's like. For anybody who has seen one, it is rightly called, in my estimation, the greatest of all natural phenomena. And take your kids because they will be absolutely hooked. So that brings it to the end of my presentation, and thank you very much. And actually, you know what? That was about 3/4 of an hour. So if there are any comments, not just questions, because a lot of you know at least as much about all of this as I do, I'd be happy to have any comments, or indeed if there are any questions.
One more thing you left off with the absolute list you have to do. Gas up the night before.
Yes, that's right. And you don't necessarily want to be using electric cars, because if you're chasing clear weather, you don't want to have to be recharging 200 kilometers down the road. But yes, absolutely, get all of that stuff ready to go. And actually, can I just talk about that for a moment, because this is, I didn't know how I was doing for time. And that is for bad weather. You will know what the weather forecasts are going to be. And the great thing about being anywhere really from Missouri to Wyoming is that for some thousands of kilometers, there will be highways that you can travel on. And I can tell you, people are all concerned, well, geez, isn't it going to be all crowded? Helen, we have driven, now I know we haven't driven for an eclipse out there, but west of the Mississippi through certainly Nebraska and Wyoming, no one lives there. There is no one there. And you can drive. You can drive for a half hour or an hour, and you won't see a car, a vehicle anywhere. And so, people who are saying, "Oh, geez, it's going to be, it's just going to be terrible." People in the states and the prairie provinces and so on are just laughing at us Easterners if we think that there are going to be problems there. Further east, yeah, obviously, because the population is 5 times as much density east of the Mississippi as west. So don't worry about that. There will be lots of time. And remember, totality occurs around noon. And the sun's going to be rising, at 5 in the morning. And so you've got lots of time. You will not sleep the night before at all, even if you think you're going to. You won't. And so you'll all be excited. They're in bed and waiting to get up. And you'll get up at 5 o'clock, and it'll be raining, and you'll think, well, crap, or other words. As we did in May 1984 for the Great Annular Eclipse. And we had gone to Virginia. I organized an expedition. We took a big bus down. Woke up in Virginia. It was pouring rain that morning. Got the weather forecast. We had a pilot who was with us. We knew there was a chance of clear weather in North Carolina. We drove 3.5 hours into North Carolina. It completely cleared up. Roared into a schoolyard. I went in, talked to the principal. There's an eclipse happening. Yes, we were astronomers from Canada. Oh, if you're Canadian, yeah, set up. And we saw it. Beautiful, perfect eclipse. You can do that. All right, and the other thing is, if you're thinking, well, gee, maybe this is something that I should see since I'm a astronomer, and you haven't yet made reservations, don't worry about getting a reservation inside the path of totality because there aren't any available. But that doesn't matter. You can be in Chicago and get up at 5 in the morning and drive into the path of totality. Get a reservation someplace out, 2 hours out, and you'll easily be able to drive in to see the eclipse that morning and then drive back. So it's very easy to do, and you can think about doing it now, even if you've made no plans up until now. Okay? Sorry, I was kind of picking up on one of the things you were saying, but you're absolutely right about that. Yes, sir.
I have 2 questions or comments. One, when you say, I saw the image, the field of view for a 1,000 millimeter lens. So that would include telescope, 1,000?
Absolutely.
Or even if they'd be super big, or a camera, right?
Yeah, what we're talking about is the focal length, whether it's a telescope or a regular camera lens of that focal length.
Okay, second point, for the people who've never, I've seen one visually just by chance, but I wasn't.
By chance? Really?
Well, I didn't know it was coming, and I wasn't really into astronomy then. That was the 1970-71 one you were talking about.
March of 1970, you just happened to be in the path?
No, actually, I learned a lot by being, I had the partial. I was in New York City then.
Oh, yeah, okay. Right.
So I looked up.
Yeah.
I used the film. I know you're not supposed to use the film, but
But you can still see me, right?
Yeah. But I put like 2 or 3 of the old films together, right? Like the black film. I looked through it. I know it's not recommended. I know that.
Ralph is having a heart attack.
I know. And I said I don't recommend it. But what amazed me was, for I guess people in 2024, it harkens back to that. It was about 80% in New York then, and the sun is still so bright when I'm looking at it, but almost a little more than 2/3 of the sun, I still remember, was blacked out, right? It was still fairly sunny out.
That's
It was
interesting.
a little cool,
Interesting point.
a little darker, but that's how powerful the sun is.
Well, yes, it is, but there's something else that's at work there, and I think it's worthwhile mentioning. I wasn't going to mention this, but it's really interesting. I thought about this a long time ago. And you do not visually detect any decrease in the light level until somewhere between 5 and 7 minutes before the total phase. Bearing in mind that the partial phase is usually about 1 hour, 20 minutes long, both before and after. You don't actually start to see anything noticeable. And why is that? Because, of course, our eyes are like auto cameras. And so as the light level decreases, it's absolutely decreasing. And by the time you get to 10 minutes before totality, you've got only about 10% of the light there. But your eye opens up, right? And so you just think, well, it's absolutely the same. And until your iris can't open anymore, and then you notice it starts to get dark. Now, there are a couple of other things that are at work there. One is, because the light then is coming from the edge of the sun, which has a different color than the center, everything starts to get kind of a bluish ashen gray. The other thing, of course, is that as the light level diminishes, as we know, as being astronomers, at lower light levels, the cones in your eye, which are responsible for seeing color, stop being triggered. And it's the rods that start being triggered, and that's why, of course, at night you can't see color. It's not that the color is there, it's only the rods that are very light sensitive but don't detect color. And so you get that same kind of phenomenon as totality approaches. So you're absolutely right. So for the first hour and 10 minutes of the partial phase, you don't notice anything going on. And that, I think, is one of the reasons why maybe in epochs, in the past, well, thousands of years ago, that people would be so startled because it would happen so suddenly. Yeah, the eclipses, it's a stately passage. It's a 3-hour event, right? But you don't notice anything happening until just a few minutes before.
My final little comment was, if it's your first attempt at photography, any suggestions to video, to a still, or you don't want to totally go nuts. So.
No, you don't. And a lot of people say that don't bother trying to take pictures. Just enjoy the spectacle, because you'll spend all of your time taking pictures and you won't enjoy the spectacle, and other people do a much better job. I'm not going to disagree with that point of view, except that I disagree with that point of view. I do both. And a lot of people say, my God, the eclipses are so short and 2 minutes goes by just like that. And I've never found that. I actually find that time kind of slows down during the total phase. And I have time to do whatever I want, to take all the photographs I want, to look around, to look in binoculars, to look all around and see all of that stuff. Part of it, if I may say, and it's not that I'm that good, but part of it is that I practice a lot ahead of time and I think about a lot ahead of time. So what exactly I'm going to do. And so as totality approaches, I'm really excited, but I'm calm because I know what I'm going to do. And if you practice ahead of time, then you can do both. Remember, you don't need to have 318 great eclipse photos. You need, 1 or 2 of the diamond ring, 1 of the prominences, then 3 exposures: inner corona, middle corona, outer corona, and then maybe if you want to do one of plants or something. And then that's going to take 40 seconds, maybe not even that. And then you've got a minute and a half where you can just enjoy it. Absolutely enjoy it. So there, 2 minutes, 40 seconds is actually a long time. It really is, at least in my experience. So that'd be my recommendation. Yes, sir.
One point to point out, I was at a friend of mine were at the May 1994 annular eclipse down in Port Tallahassee, and just around during the maximum eclipse, it was more like a silvery gray on all the colors. So like the green looked like a tinge of silver on it. So you'll probably get that about maybe 10 minutes, start getting that about 10 minutes.
That's what I was trying to convey. You're absolutely right about that. And that's a really neat phenomenon,
It
actually.
looks weird too. I mean,
it does.
The colors look totally different.
Yeah. It's a neat thing to see, really neat thing to see. Even without any fancy equipment, it's just what you can see, right? Right.
I'll have my telescope and mount, and if I can see the eclipse from my campsite, it will be polar aligned from the night before.
Absolutely, same.
But if 2 days before, lousy weather here, drive to Alliance, which is 1,000 kilometers west.
That's my backup site too.
Yeah.
Little town of Alliance.
So hints on polar aligning in the daytime?
Yeah, okay, so a couple of things. First of all you need is a very rough alignment. That's all you need is a rough alignment. And I mean even within 5 degrees. Because remember, for photography, they're very short exposures. And if you have to correct the declination a little bit, every 10 minutes or so, who cares? It doesn't really matter. But two things. One is have an inclinometer with you, so you'll be able to get based on your latitude, within half a degree, or at least 1 degree of the proper elevation above the horizon. Second thing is find out where have a compass with you and go to magnetic deviation charts for North America and find out what the magnetic deviation is for your location out there. I've already done that, and that will tell you when you're using your compass. You'll obviously have magnetic north, and then you have to use the magnetic deviation to find out where true north is, and that's where you set up your deck axis spacing. And you should be able to get within 3 or 4 degrees without doing any kind of tracking of the sun and north south and all that kind of crap. Don't worry about that at all. When I do all of my lunar photography, I just grab the scope, put it outside, face it approximately. Oh yeah, North Star is still there, approximately there, and I'm within 8 degrees, and I do my photography, and it turns out not too badly, So don't worry too much about that, and get really bent out of shape about alignment. I won't worry too much about it. Anything else before I turn it over to Ralph? Okay, well again, yes sir.
Mike, any thoughts about photographing the shadow bands?
I didn't even see you. How are you?
Very well.
Sorry. Yes, two things. All right, so now that you've mentioned shadow bands, let me just do 30 seconds. Shadow bands are a very, very weird phenomenon that can be seen at some eclipses and not at others. They are very rapidly racing bands of alternate shadow and light that race across the ground. Generally in the direction that the shadow is moving, but they without getting too much into that, it is thought to have to do with atmospheric effects caused by the very thin crescent of the sun, and that light coming through in a very thin beam, and then being displaced by atmospheric turbulence. And you don't see them very often. What we always try to remember to do, and we did this in the Philippines, I was reminded when I saw Randy's video, is we took a big white bed sheet, and put it out on the ground. And in the video that we were watching last week, I saw myself saying, look, about 3 minutes before, look, shadow bands, they're racing across the ground. I'd forgotten all about that. So it's a really neat thing to see. However, the contrast is extremely low. And I'm going to liken it, I'm going to give you an example. If you take a pencil or a pen and you hold it over a table with a light source, and you just hold it there, as long as it's not a pinpoint light source, but it's an extended light source like the sun, you can't see the shadow even if you're holding it 30 centimeters above it. You can't see it. Now, move it. Suddenly, you see it. It's the movement that catches your eye, because the contrast between the darkness in the shadow and the lightness is really low. And I'm talking 1, 2, 3%. So while you can see shadow bands racing, that's one of the reasons why there are just so few photographs at all, or decent photographs at all, of shadow bands. However, having said that, with film cameras, it's really, really difficult, I think. It might be worthwhile trying it. First of all, get a white sheet. You got to do that, absolutely. Second, you obviously want to use a very fast shutter speed, and you don't want to overexpose. So what I would suggest is turn your camera down to -1, something like that, 1 stop below, and then shoot a very fast shutter speed. And if you're, and using something like ISO 400 or maybe even 800, then in Photoshop or some photo processing software afterwards, boost up the contrast. And if you got any chance of seeing it, that's how you will see it. So, and I don't know, because I've never photographed them successfully. But those are some thoughts about that if people want to try that, and if in fact they're visible at this eclipse. Sorry?
Video instead of just...
maybe, I don't know. I really don't know. I just can't say, Peter. So I don't know. If anybody, I'm hoping just to see them. But of course, the other thing is a lot of people miss them because, you know, they're on the ground and you're generally doing this. And so you're kind of not looking in the right direction, but take the time to do that. Okay, you know what? I've used up enough time. Ralph's got a lot of important things to say. So Ralph, I'm going to take this off, turn it over to you. And again, once more, thank you very much.